Okay, guys, when we left off, I told you guys to pick a section at the end of the note or at the end of the chapter and start a list of triangle congruence theorems. Okay, and so far, which are basically going to be the shortcuts we can use to showing triangles are congruent, because by definition you have to show all 6 parts. So we learned the first shortcut last time, and that was the side congruence postulate. Today we're going to add to this list. So what we're going to do today is learn the side angle side and hypotenuse leg congruence theorems and postulates. So first of all, the vocabulary. The vocabulary you guys should have learned in previous classes. When we have a right triangle, we name certain parts of the triangle different things. So in a right triangle, okay, right angle there, you've got 3 different sides. 2 of those sides are called the legs. They will always be the shorter sides. Okay, so those are our legs. And then the longest side is the hypotenuse. Okay, this side is the hypotenuse for this right triangle. One kind of simple way to remember which one is the hypotenuse, or tell which one the hypotenuse, if you think of the right angle symbol as an arrowhead, that arrowhead is pointing towards the hypotenuse. And again, the hypotenuse will always be the longest side. Alright, so that brings us to our first congruence postulate for today, and this is the side angle side congruence postulate. Now, the order that those letters go in matters. When we say the side angle side, okay, side angle side, we're saying that we have 2 sides of the triangle and the angle that is in between those 2 sides. Okay? So 2 sides of the triangle and the angle between them. If that's congruent to 2 sides and the angle between on another triangle, then the 2 triangles are congruent. So again, when it says the included angle, it means the angle that's between those 2 sides. So for our picture here, if we have segment RS is congruent to segment UV, angle R is congruent to angle U, and side RT is congruent to segment UW. Okay, if we look, that's 2 pairs of congruent sides, and the angles in between them are congruent. Then we can say the triangles are congruent. And again, don't forget to line up your corresponding parts. So triangle RST is congruent to triangle UVW. All right. So again, that is the side angle side congruence postulate, and we'll abbreviate that SAS. All right, here's an example of a proof that uses that. So, first of all, this picture is drawn kind of incorrectly. Correct the picture if you can. To correct the picture, redraw it like I have here. Okay, again, the way it was drawn in your notebook is incorrect. This is the correct drawing. So let's go ahead and do our proof. So like always, we're going to start our proof with the given statement. So JN is congruent to segment LN, KN is congruent to segment MN. And it's already done, but don't forget to always mark your pictures when you write it in the proof. Now if we look, that's 2 sides for the triangle on the left, congruent to 2 sides for the triangle on the right. So if we can show the angles between those sides are congruent, then we can use side angle side as our shortcut here. And sure enough, we've got angle 1 is congruent to angle 2, and the reason for that is the vertical angles congruence theorem. Or usually we just write vertical angles are congruent. Okay. So now I've got my 2 sides, I've got the angles between them. So triangle JKN is congruent to triangle LMN. Notice corresponding parts are all lined up, and our reason for that is side, angle, side. Okay, so that proof is done. All right, in the diagram, ABCD is a rectangle. So all the stuff you learned in elementary school about rectangles is true. Opposite sides are congruent, the corners are right angles. What can you conclude about triangles ABC and triangles CDA? CDA. And I think if yours like mine, it might have forgot to label D there. Okay, so if we look at that, we know by the right angles congruence theorem that all right angles are congruent. So angle B and angle D are congruent. Opposite sides of a rectangle are congruent. So segment AB is congruent to segment CD. Okay, mark that on your picture. And segment BC is congruent to segment DA. So segment BC, segment DA. Now if we look, again, I've got two sides on this triangle, the angle in between, congruent to two sides on this triangle, and the angle in between. So triangle ABC and CDA are congruent by side, angle, side. So this is this is a paragraph proof here, where the first example was a two-column proof. All right, so now it is time for you. One kind of trick on proofs, or not really a trick, but a hint, is use your colored markers or colored pencils, whatever, and highlight what you're trying to prove. For example, on this one, we are trying to show that triangle DMY is congruent to triangle BMY. So you're trying to show that the blue and the green triangles are the same shape, same size. So this up here is your given information. Go ahead and write a two-column proof below that. Okay? So go ahead and pause the video, write your proof, and then we'll come back and go over your answer. One hint on this, one thing that you will use, is that the definition of a circle is it's all points that are equidistant from the center. So whenever you want to say any radii of a circle are congruent, you can, and the reason for that would be definition of a circle. That is definitely going to come up in this proof. All right, so go ahead and finish it and then come back and check your answer. Okay, so here are the statements. Let's go over the reasons for each of these. Now, we know that angle 3 is congruent to angle 4 because that was given. And as always, whenever I say something in the proof, I'm going to go ahead and mark it on the picture. After that, we've got segment DM is congruent to segment BM. This is the one I was trying to give you the hint on. That is the definition of a circle. And that's our symbol for a circle. It's a circle with a dot in the middle. And go ahead and mark that on the picture, DM and BM. Next one, segment MY is congruent to segment MY. Notice the two triangles share a side, so we're going to say that side is congruent to itself. The reason for that will be the reflexive property. And mark that on here. So there we go. So if we look at our triangles, we've got two sides on one congruent to two sides on the other, and the included angle, the angle between those two sides, is also congruent. So we can say that triangle DMY is congruent to BMY. Match up your corresponding parts. So triangle DMY is congruent to triangle BMY, and our reason is side, angle, side. Now, one thing I want to say before we go on, the first three steps in this proof, okay, neither one depends on the other one. Okay, so you could have written those three statements in any order, but all three have to come before you make that final statement number 4. Okay, so if we look, angle 3 congruent to angle 4, that was our angle. DM congruent to BM, that was one of the sides. MY congruent to MY was one of the other sides. And if we look back at the picture, they are all in the right arrangement, the two sides with the angle between them. All right, so here's our second shortcut for today, third overall, which is the hypotenuse leg congruence theorem. Now, for this one, you have to first say that you are dealing with right triangles. Okay, right triangles are the only ones that have hypotenuses. So, in order for this to be hypotenuse leg, you have to first say that you have a right triangle. And this says that if the hypotenuses are congruent and one of the legs is congruent, then you can say that the two triangles are congruent. Okay, and we will abbreviate this one HL. Notice that is still 3 parts of the triangle because you know the right angles are congruent, the hypotenuse and the leg, so that is 3 parts altogether. All right, I would like you guys to try and do this proof on your own. So go ahead, pause the video, and go through example 3. It's basically filling in the blanks. So let's see how you can do. All right, so here's all our blanks filled out. I do kind of want to explain this proof, though. So we're going to start out. They gave us that AC and EC are congruent. So I put that in for statement number 1. The reason is given, and that is the hypotenuse that I need. Okay, that's what the little H out in front stands for. That is the hypotenuse. Going on to statement number 2. Now we're looking at the two perpendicular. You could have written that all as one statement. That's fine. They split it up because it kind of makes the logic flow a little better. If we look at those two perpendicular segments, okay, AB congruent to B, or I'm sorry, not congruent, AB perpendicular to BD, and then ED perpendicular to BD, is those two angles. Okay, so statement number 3, perpendicular lines means we have right angles here. So if we have right angles, then I can say that I've got right triangles. Okay, definition of a right triangle has a right angle in it. That's important because if I'm going to use hypotenuse leg, that only applies to right triangles. So I have to say that I am dealing with right triangles. That needs to be in there. Okay, so after that, then we need to show that our leg is congruent. The leg being congruent is going to come from the bisector part of this. So segment AD bisects segment BD. All right, and again, that was given to us. So bisector means it cuts it in half. That gives us BC is congruent to DC. And don't forget to mark your picture. And the reason of that is definition of segment bisector. And that is the leg that I needed. Okay, so I have got my hypotenuse and my leg, and I said that it is a right triangle. So that is all the information I need to conclude that triangle ABC is congruent to triangle EDC, and the reason is hypotenuse leg. All right, example 4 here. This one, it's another one of those, it's kind of silly, but we'll go through. You'll see problems like this without them trying to make it a gate or whatever. So the entrance to a ranch has a rectangular gate. So notice that word there. You know that triangle AFC is congruent to triangle EFC. Okay. What postulator theorem can you use to conclude that triangle ABC, okay, so triangle ABC is congruent to triangle EFC? Okay. This one here. What postulator theorem can you use? Oh, sorry, I just said that. ABC to EDC. Oh. You know what? I just realized I messed that up. Let me back up a little bit here. It is triangle ABC congruent to triangle EDC. There we go. All right, so we're given that ABDE is a rectangle. So angle B and angle D are right angles. Okay. You said it in the proof, mark it in the picture. Because opposite sides of a rectangle are congruent, we know that segment AB is going to be congruent to segment ED. Again, mark it on the picture. You're also given, now this is where the proof gets a little bit different. We're given that triangle AFC, okay, AFC was congruent to triangle EFC. So I can say that AC is congruent to EC. Okay? So AC is congruent to EC by the definition of congruent figures. Definition says that all the corresponding parts are congruent. So that's the hypotenuse and the leg of each triangle is congruent. So we can use hypotenuse leg to conclude that triangle ABC is congruent to triangle EDC. Sorry about the little mistake on that one. Okay, checkpoint number 3. Explain why the diagonal of a rectangle forms a pair of congruent triangles. I would like you to try and think of at least 2 different ways that you could prove this one. All right, so go ahead and pause the video and write down why you think that would be true. Okay, so the first way we can do this, we can say, well, if it's a rectangle, then opposite sides are congruent. So in my picture here, BC is congruent to AD, segment BA would be congruent to CD, and they share a side, so BD would be congruent to itself by the reflexive property. So I could put all that together and say that the 2 triangles are congruent by side, side, side congruence theorem. I said try and think of a couple different ways, so let's draw the same picture. We've got rectangle ABCD here. We've got one of the diagonals drawn. Well, I know it's a rectangle, so still the opposite sides are congruent. So again, BC and AD, AB and CD. That's 2 sides of one triangle congruent to 2 sides of the other one. And I know it's a rectangle. Rectangles have right angles. So angles A and C would both be right angles. They're both congruent. So notice, now I have 2 sides of one with the angle between congruent to 2 sides of the other with the angle between. So we could have also proven that those 2 triangles are congruent by side, angle, side. Let's look at a third way. So same picture. ABCD here, rectangle ABCD, and we know it's a rectangle, so we know the corners are right angles. That means I have 2 right triangles. Opposite sides of a triangle, opposite sides of a rectangle are congruent. So BC and AD are congruent. That's a leg on each triangle. And BD is congruent to itself. That happens to be the hypotenuses. So I can say that the triangles are congruent. And it would be triangle ABD is congruent to triangle. That would be CDB. That would be the same congruent statement for all of them. And here the reason is hypotenuse leg. So we could have used any of the 3 shortcuts we've learned to solve this one problem. Now that's not always going to be true. In fact, most of the time it'll definitely be one of the shortcuts that we can do. But I just wanted to point out that this problem, you could have solved any of the ways. We're going to skip checkpoint number 4. All right, now, a couple things before we go on. We've been learning shortcuts for these. Not all shortcuts work. Okay? If you look, both of them today had 2 sides and an angle in it. Okay? What's important is that the angle is either a right angle, and we're talking about hypotenuse leg, or the angle is between the 2 sides, so we have side angle side. Well, would this work if we had the angle outside of the 2? All right, when you guys stop giggling, we'll go over the explanation here. And the answer is no, that won't work. Let me draw a couple triangles here to give you a counter example of why angle side side does not work. So let's say I have this triangle here, and then I've got this triangle here. You will notice that they each have a congruent angle. These sides are congruent, and then following around in the same direction on each triangle, these two sides are congruent. So congruent means same shape, same size. Here we've got two triangles that are definitely not the same shape, but it does have an angle and then the two sides around that. So here's a counterexample. The order that they're written in is important. It matters. These are not congruent. This is not a congruence postulate. You will never use angle side side. It doesn't work. Here is your counterexample. All right, so to wrap up, basically we learned two new congruence postulates. So go to wherever you put your list at the end of the chapter and add side angle side and hypotenuse leg. And as we go through the chapter, you'll add a few more. You've got to know these. You've got to know which ones work, which ones don't work. Okay? So that's it. Have a good night, everyone.